So in today's lesson, we're going to be learning about how to use unit conversions to solve real-world problems. Now, if you're referencing our Springboard text, you're going to find that starts on page 223 with section 18.1 and goes until page 226. Now, at the end, we're actually going to do problem 4 on page 226 as a sample problem, which will help you if you get stuck on your homework. Okay, so as we're looking at the textbook here, we have some vocabulary that we are going to need to be familiar with in order to succeed in understanding the concepts in this chapter. So we're looking at dimensional analysis, which is a really complex sounding word, but isn't really that hard. It's really just a method for us to compare values in the same way. So we've heard the phrase apples to apples. We can only compare apples with apples. So if I'm talking about feet, when I'm comparing it to another thing that's in inches, well, in order to compare that more easily, I'm going to convert them both to the same unit. So I'm either convert them both to inches or convert them both to feet. And to do so, I need to know my other vocabulary word, which is conversion factor. Conversion factor is where I change the form or unit of a term by multiplying it by something that's equivalent to 1, a fraction that's equivalent to 1. An example of that would be if I was doing feet to inches. So I'll show you one right now. All right, so a good example would be if I was trying to figure out how many inches are in 3 feet. Well, I know that if I have a value of 3, that is a whole number, so as a fraction it's going to be over 1, and in a conversion factor I'm going to be multiplying by a fraction that has the value of 1. So if I'm multiplying here, I know that there are 12 feet in 1 inch, and in my problem I'm trying to go from feet to inches. So I need to cancel out this feet value and convert it into inches. So if I have units that are on opposite side of the fraction bar, that's going to cancel out. So if I'm multiplying this by a conversion factor, the conversion factor would be in 1 foot, there are 12 inches. And we are familiar with that piece of information, but it's important to note how I wrote it here. 12, the inches is on the top. Inches is what I'm trying to end up with. Feet is on the bottom. Feet will cancel out. It needs to be on the opposite side of the fraction bar as the other unit, which is the same unit, to cancel it out. So in this case, feet is going to cancel out because they are on opposite sides of the fraction bar, and I will be left with only inches. So now I have to actually do the multiplication. I have 3 here, 3 feet times 12 inches. I know that 1 times 1 is simply 1, so whatever my operation here of 3 times 12 is going to leave me with a whole number. So 3 times 12, which results in 36. My other units canceled out. Feet and feet canceled, so I'm left with only inches. So while you may have known that there are 36 inches in 3 feet, this is a way that allows us to make multiple conversions, which is a process that gets a little bit tricky when we start to go from, say, yards to inches or from years to minutes. Those are conversions that take multiple conversion factors to get to our solution. So in our vocabulary words here, this 12 over 1, 12 inches to 1 foot, is our conversion factor. Now we see with that conversion factor that there are 12 inches in 1 foot, so really when we're multiplying, we're only multiplying by 1. When we multiply anything by 1, our value stays the same. So we can use this in dimensional analysis, which would be in one of our problems where we are trying to compare two things in inches. We would know if one of them was in feet, we could change it, convert it over to inches in order to make our comparison a little easier. Okay, so as you can see here, I took a problem straight from your Springboard homework. This is actually one on 226 in the lesson practice for 18-1. In this problem, we're trying to find the answer to that Chris found out that animators earn an average salary of $46,885 per year. He wondered how much an animator earns per month. This is broken down because they're still trying to help us make sure we can convert these into two different sections, A and B. So for A, what it's asking us to do is figure out what conversion factor we're going to use to convert dollars per year to dollars per month. Now I want to point something out here. Dollars doesn't change. We have dollars here, we have dollars here. The thing that does change is the time period in which we're looking at. In this one, we're looking at per year, and in our answer, we're trying to get per month. So if we're going down to that marking the text and trying to figure out what the problem is actually asking us, we're going to make sure that we're marking that in the question, it's asking us how much an animator makes per month. Now, it's important that we, in the end, we end up with per month. Okay, so if we're going to our part A of this question here, what is the conversion factor to convert dollars per year to dollars per month? I'm going to start off with the information I'm already given. Well, I'm given that there's 46,885 per year. So I'm going to go ahead and write that out. So 46,885, pardon my poor handwriting here, it's a little bit difficult on the iPad, and this is per, so remember per means the fraction bar, per 1 year. Okay, so it's asking me what conversion factor I need. Well, I'm trying to go from years down here, and eventually I want to get to months, and I want that to be my final answer. So in order to convert this, I have to make sure that I am multiplying, remember multiplying by our conversion factor, and if years is at the bottom here, I know that years is now going to be at the top on my conversion factor. So I'm going to draw my fraction line, and I know that I'm going to be working with 1 year. Well, in how many months are in a year? Because remember, if we go back to the problem, I'm trying to get to months right here. So I know that there are 12 months in 1 year. So in doing this, I have answered A right here by saying that I'm going to use the conversion factor 1 year per 12 months. And you'll notice that when if I look back to my units, that years is on the bottom of the denominator of the fraction here, and is the numerator of the fraction here. So those will cancel, and I will be left with just months, which is what the problem is asking us to do. Now if I go to B, it's asking us to actually do the math and show my work and see what the average salary actually is. Well, when I'm multiplying by fractions, I multiply straight across. So 46,885 times 1 is simply going to be 46,885. And same thing here, when I multiply 1 times 12, I know that 1 times 12 is simply going to be 12. So now I have to go back to that math that we always say in the classroom. A fraction is a division problem. So here, I got to be careful here because I have my 46,885 per 12, and what is my 12? My 12 is months. I want to keep that unit on there. So, a fraction is a division problem here. So I just have to divide 46,885 divided by 12. Now, I'm confident in your long division skills. On a problem like this, if we were taking it on a test, you would be allowed to use your calculator, especially with when it's not going to come out to be even, like this problem will not. When you divide 46,885 by 12, your solution is that $3,907.08. Now, I rounded to 2 decimals. This makes sense because we only have 2 decimals in money. We don't usually think about tenths of cents when we're talking about money, so $3,907.08, and once again this is per, so that's where my fraction bar goes, month, which was what I was looking for in my answer. Now I'm going to go back and check it just to double check that I ended up with the unit that I was supposed to. So my unit here is $3,907.08 per month. In my question it says how much per month. Going back and checking, that's why that marking the text is a big point here. Going back and checking, making sure that you've done all the conversions necessary in order to fully answer the problem. Okay, so going back to our learning objectives here, that you can use a unit conversion to solve real-world problems. This is definitely a problem you would find in the real world, and we did use a unit conversion in order to solve this. We will be going over this more in the days to come in class, and these conversions are used in science a ton. So we will be get much more practice with this. Look for future videos coming up on converting between measurements, also using ratios, and that we'll do an extra one on degrees to Fahrenheit degrees to Celsius. So take a look for that video in the upcoming weeks.